Hello, I'm Eric Snodgrass, and thank you for watching this Friday morning in-depth ag forecast brought to you by Nutrien Ag Solutions. First of all, thanks for giving me an extra day to kind of get this done. Yesterday was a travel day for me coming home from the West Coast where I was for most of the week. And as I came home, I was really quite interested to see how this whole lake effect snow event was going to play out. So let's start there. The first map we're going to look at is showing the current water temperatures for the Great Lakes. And if you just kind of look at the color bar over here on the left, you can see how warm much of the Great Lakes are currently. And these very warm conditions are critical to get the lake effect snow machine going. You have to have a temperature differential between the surface air and the air about a mile above the surface to be at least 13 degrees Celsius. And we're getting that right now because we have very strong winds that are coming out of this large Arctic high that's pressing from the northern plains and Canadian Prairie all the way across the Great Lakes. And this has been the second really big push of colder air coming in here. We do have wind chill warnings that are out for parts of the northern plains with this. But if we kind of zoom in here and have a look, here's something just to think about with this setup of lake effect snow bands. Because of the orientation of the lakes, when you get winds like this, you tend to get what are called wind parallel bands. They kind of come across the lakes like this for like Lake Michigan, Lake Huron, but you get what's called a shore parallel band coming across parts of like Lake Erie and Lake Ontario. And it's those shore parallel bands that can just, I'll be honest, they can deliver a tremendous amount of snow in a short amount of time. So we need to see this setup and see how long this is going to last and just have a quick look at it here. So I was looking at some of the surface observations this morning, and I know it's kind of a dense plot here of what's going on, but I was looking at the change in temperature going across the lake, and I was also looking at some of the intensity of the snow. But as I was kind of zooming in here, you can see that on the tip of Lake Erie, that symbol right there, okay, is the symbol for thunderstorms actually. So we had thunder snow in here with a particular setup. And you know, one of my favorite resources for lightning, it's free, it's blitzertongue.org. And if you go there, you can get right to this site right away. Now, a couple of fun things to do when you get to this site. You can, for example, look at historical data. So why don't we just do that just as an example? I'm going to click on historical maps. It's going to give me a 6-hour loop right off the bat. I can change this to 12, whatever you want to do. But I was looking for this. See the lightning here right on the edge of Lake Erie and also coming across Ontario. And we're going to talk about why that is the case, but just kind of an interesting personal story here. Back in 2014 up in northern Wisconsin, my dad was struck by lightning. He survived the event. And after I found out he was okay, I actually went to blitzertongue.org and saved the lightning data and found the positive polarity strike that hit the tree that my dad was standing near while trying to open the door for my mom on her birthday to take her out to breakfast. So just an interesting side story there for you. But what's giving us the ability to have convection? That's what I want to talk about. This is rapidly rising air to produce lightning like this. So we're going to go straight to a sounding. Now, this was this morning's sounding, so this is the weather balloon data from Buffalo, New York. And so you've got here two lines that you can see pretty clearly. The one on the right is the temperature, and the one on the left is the dew point temperature. So we're saturated in the lower levels of the atmosphere. Now, the temperature in Buffalo, where this was launched, is 29. But you saw earlier that the lake temperatures, as you go across, for example, Lake Erie, we're talking about some of the lake temperature here that's still in the upper 50s. So if you modify that boundary layer air as it's going across the lake, what ends up happening out there is that the surface air temperature is probably closer to about right here. So what that does is that actually gives you a temperature profile that does something like this. And that is what we call superadiabatic. In other words, the rate at which the temperatures are decreasing in the lowest couple hundred feet of the atmosphere are so fast that the atmosphere rapidly overturns and just shoots up convection, just straight up. And then you get this very rapid transfer of heat and moisture off of the lake, and you build these absolutely incredible convective clouds. And you can see them here. So this is just looking at some of the satellite data. And it's a neat thing to see too is that oftentimes as the main band builds right here in the middle of the lake, you get clearing on either side. This is the air that's coming in and rising right here on the center. It's a really neat thing to see. But these little storms, honestly, are packed full of snow, and they're really delivering it on the tip of Lake Erie and in Ontario. Now, this is a very hard thing to forecast. Where will that heavy snow be? Will it be here? Will it be a little farther to the north? And that's why we have experts of the National Weather Service forecasting these things, because it's a challenge. Same thing with what comes under the Tug Hill Plateau. Interestingly enough, we do see this morning, watch the animation under where I just kind of drew that circle. There appears to be the beginning of a lake effect vortex. So a little, mesoscale, almost micro scale low that has spun up right here. And sometimes it can even take on the appearance of a hurricane, a small one, but they, of course, don't have hurricane characteristics. So that's it. This is kind of what's going on today. And as we watch this, we're keeping an eye because the snowfall rates could easily top 3 to 4 inches an hour. And even today, right here near Buffalo, we're expecting 8 to 12 inches just this afternoon. And then as you get into the evening, maybe another 8 to 12. And the total snowfall from this entire event is going to max out some of the model forecasts. So I'm showing here the National Digital Forecast Database on what to expect over the next about 72 hours. And you can kind of zoom in here and just see that some of these areas are going to have hyper-local, very heavy snowfall amounts. Well above 3 to 4 feet is possible out of this. Now you tend to get less on the wind parallel bands coming off of Superior, Huron, and Michigan. But still, there's the possibility of 6 to 10 inches on these sides of Superior and Michigan, especially with this. So I just thought I would kind of give you a quick briefing on how that works in case you hadn't heard. A lot of you, I'm sure, understand how the Lake Effect Snow Machine works, but just thought I'd include that today. Okay, what got us here is what I really want to dig into because I'm going to give you this new long-range update, just some additional information, and I want to talk about some important factors going forward. So from about the 10th of November to the 15th, we saw this cross-polar ridge develop. We've talked a lot about it. And when that happens, you just tend to get this highly amplified flow. And that's what's been delivering these shots at colder air that have come through the plains, parts of the west, out of the Canadian prairie, and just over the last few days have really dove into a deep trough that's now anchored right here. Now, you're not seeing that in this image, but that's where that trough was anchored. Now, because of this, we've kind of let go of all of the very cold air that had been stored up here, and it's now spread in these directions and has completely overtaken much of the eastern half of the United States. Look at the warmth compared to normal over the last 7 days that is built under that ridge, and it's reflected over in Scandinavia as well, which is where that cross-polar ridge sets up. Now, when we looked at this, the connection between the tropospheric polar vortex, that's the deep trough that's currently sitting over the Hudson Bay and the Great Lakes, versus the stratospheric polar vortex, I didn't see as strong a connection as some of my fellow meteorologists did. But I want to make a comment about the stratospheric polar vortex, okay? Now, we'll look at these images quite a few times over the next, 3 months. And what it is you're way up in the stratosphere where the pressure's 10 millibars. Now, last year is in the blue line. We had a very strong polar vortex until the very end of winter when it really just fell apart. But that was a late disruption in the polar vortex and therefore didn't have the same kind of influence on the temperature patterns that it can have in December, January, and February. So last year, the polar vortex built quite a bit of strength and maintained it until the very end of winter. Currently, we're sitting here. So the polar vortex has recently lost some of its strength. Now, just remember, a weakened polar vortex is the one that can allow a lot of cold air to move away from the polar regions, link up with the tropospheric polar vortex, and spread cold air, sometimes up to like 10 to 20 days in duration, massive cold air outbreaks. Now, do we expect to have a year where the polar vortex stays weak? That is a possibility. I'm going to explain to you why I'm concerned about that and why for the last several weeks we've been having this narrative that this upcoming winter does have the risk of seeing multiple shots at some really cold air, especially in the northern tier of the U.S. into the east. And then also we may see the same thing happening across Europe. So we're building that narrative, and this is one of the things I'd like to share with you about it. So in October, take a look at the map that's over here on the right. This was snow cover compared to normal. And you notice that across much of Russia, Siberia, snowpack was really quite impressive. And now when you look at it, across the whole of the northern hemisphere, we've built up a tremendous amount of snowpack for this time of year into November. And why this is so important is that snowpack during this time of year affects the heat transfer from the surface of the atmosphere into the lower atmosphere. It also affects the way that sunlight is reflected. It has a feedback such that it can continue to cause deep, cold air to reside over the land masses. Now, keep that in the back of your mind. I want to show you something here from AER. I believe this work was done probably by Judah Cohen. Brilliant guy, love his stuff, but I want to show you this. What he did was they put together a timeline. And we're going to follow the high snow cover years. Because whenever there's big snowpack in Siberia in October, which I just showed you they had, look at this, you induce surface cooling, strengthening the Siberian high. All right? Now, if that occurs, you get an amplification of the tropospheric jet stream. That's the piece that comes across the Pacific, ends up in the Atlantic, right? And so we need to watch for that because that is ultimately going to be the thing that drives the systems across both North America and Europe. You tend to have a weaker, look at this, a weaker polar vortex in December going into January. And that particular setup means that we increase the risk of this. A negative Arctic oscillation, and probably a negative North Atlantic oscillation. And those two things, if you've been keeping up with the videos, often result in better or higher probability of dropping cold air across the eastern half of North America and across Europe. So you see how we're kind of stitching these things together. There's another component to this as well, and that other component is we've got quite a bit of warm water here and some warm water that extends into the North Atlantic. So if you can just imagine, we're going to push warmth here and here, and as a result, it tends to come out there and there during this time of year. And we've certainly seen that happen as of late. So what we're trying to do here is just construct this story about winter, and I'm going to pick that back up with you in just a few moments. Now in the near term, that big blocking ridge, see the one that's here, and there's the cross-polar feature coming off of Scandinavia. And again, this is what's driven all of that cold air into this trough here, and there's even another one over parts of Siberia. Well, we know that this is getting pushed out, and we've been talking about the momentum getting carried from the Pacific off of Japan to undercut it. So what we see is that going through Saturday into Sunday and Monday, we've now opened the pattern up. It's moving again. We've gotten rid of the deeper trough, and now we're seeing something that's doing a bit more action like this. Now that's just a more fluid and more moving jet stream pattern. Now what's changed here is that as we approach Thanksgiving, one of the model trends we watched all week was that instead of this trough being closer to the west coast of the United States, like where I just drew that arrow, we've now got a ridge that's building in here. And so as a result of this, this is going to delay the arrival of better precipitation to the west, possibly not until the very end of the month of November, But to see a trough forming here and a trough forming there with the ridge in between, this is an MJO phase 6 look if I've ever seen one. So what that means is we've, unfortunately, because of I just wasn't able to capture it and see the evolution of it, I think we're going to have to kick the can down the road a little bit on when the really wet conditions could return to the western United States. Now there's another thing that's happening in between there, and that's going to happen on Thanksgiving, and I got to talk to you about what I'm expecting to see there. But ultimately, over the next week, because of that pattern, remember the ridge is building here and the trough still in place, that's missing the west coast. All the moisture is going into British Columbia. There's more mild conditions coming into the west. And overall, a big section of the United States is drier because we're pushing that colder air farther to the south. Your wetter conditions are down here at the base of the trough. So let's do this. Let's also see how long that colder air is going to last, and then I'm going to talk about what I'm watching for Thanksgiving. So this morning, our freeze line made it all the way to the Gulf Coast and East Coast and parts of Texas. As we get into Saturday, it remains there pretty close to into the south, approaching the Gulf. But watch, by Sunday, we're going to watch a retreat of this going into Monday and Tuesday. Look at that. Moderation in this pattern is coming. And as the ridge opens up back west, by the time we get out to Thanksgiving, we're going to be seeing more mild conditions across the country. Now, this was the minimum temperatures. Let's go take a look at the max. So today, that Arctic front is really penetrating pretty far to the south and east. It's mild along the west coast. As we go into Saturday, another cold one for much of the U.S., but by Sunday, we're going to get some downslope flow here coming off the mountains. It's going to help warm things up a little bit, and we're already going to see temperatures coming back into the 50s. Let's go from Sunday to Monday. You're going to start to see some national moderation in the temperatures, especially into Tuesday and Wednesday and Thursday of next week. So we're going to lose this Arctic signal, and actually some warmth is going to be moving back into the west, and you know why. That's when that ridge builds back into the west. Now, what I want to talk about is how the models are responding to this, and we've got major disagreement once we get past about next Tuesday. Let's talk about the European first. Now, here's a lake effect snow, deep trough, high pressure builds in, and it's going to suppress any moisture and keep it pretty far to the south. So from southern Texas along the Gulf Coast, yeah, we could see some precipitation there. And even later today, maybe some ice, sleet into this area of Texas. That's today. This is on Saturday, though. As we then play through the weekend, we have our next little shortwave that cuts through the Great Lakes, some more lake effect snow here. But outside of that, much of the country's dry. Now, next Monday, we get a full breakdown of the ridge. Flow comes into British Columbia, and I'm watching very carefully for a shortwave to make its way through this flow and eventually hit parts of the Pacific Northwest, but more British Columbia. Now, what we're going to see here is that wave, there it is, Tuesday, is going to be linked up with the possibility of a system that, watch again, see it coming over the Pacific Northwest. This is getting out there Tuesday night, Wednesday morning, maybe coming over Montana. What I'll be watching for at this time is this shortwave cutting into the northern plains, the western Corn Belt, the Midwest by next Thursday around noon. The European model latest run puts a low right there, opens up the Gulf, so there'll be some storms to the south and curls stuff around for snow on the backside. In fact, that's what it looks like on Thursday evening, getting through Friday morning. Big dry slot on the backside of this. Storms in the southeast, going out there into Friday midday, Friday evening, and finishing out the weekend with possibly a large winter storm across the eastern United States. Now, that's just one single model simulation, and the GFS doesn't play along. It's got the same features going through Saturday into Sunday. Here we are into Monday and Tuesday. So there's a wave coming in here Tuesday. But look at all the wet weather it's got farther to the south. The GFS has got this pattern quite a bit different. You see, the model is attempting to take that low that came into the northwest and leave it here and not link it up with opening up anything out of the Gulf. So the system rolls over the Great Lakes and then builds quickly from Ontario to Quebec. That's a much less, potent system for the East Coast. Now, this is still a week away from when I'm recording this, which means we have a lot to be watching change. And what's really amazing is the shortwave that's going to do all of this, today, it's this guy right here. That's it. That is the little wiggle in the flow coming off of Japan that we have to watch evolve, coming all the way across the Pacific Ocean, come into British Columbia, and then dive. So this is it. That's why there's so much uncertainty. And the ensembles are not picking up on that very well either. So what we're watching is this. I'll just park you out there next Thursday. This is a map of vorticity, spin in the atmosphere. And what I want to do is I'm going to compare the European model, which you can see next Thursday morning into the midday, afternoon, and evening, drops a deep trough right here. This is why it spins up a larger system that then exits quickly into New England. That's a monster system should it form. Well, the difference is this is what the GFS says. Same time, that is a much farther north position of the trough. And as a result, it sweeps the system through here and drags a front that doesn't have much moisture to work with. So the difference is the European dives the system down and pulls it straight through. The GFS keeps it farther to the north and runs it up through parts of Ontario and Quebec. Now, we're looking at nuanced features 7 to 8 days out in the future. So much is going to change about all of this. But it'll affect total snowfall. Until we get to that system, let's go out there and I'm going to stop this on Thursday. That's right there, Thursday evening. Most of it's going to be some light snow showers, heavier snow from parts of Manitoba through Ontario into Quebec, and then the lake effect. The GFS actually sees the same thing. It's what happens once you get past next Thursday that's going to be interesting, and I don't think we should look at any any individual model run, but instead have a look at the ensembles. So to show you that there's a lot of uncertainty about the end of next week, this is the 10-day outlook for the probability of 3 inches. So we just see by looking at this that setup for late next week is not set in stone. It's something we're going to have to watch the trends on all week. We'll have a better picture on this on Monday when I next talk to you. Okay, from here, where are we going? Well, this is when the pattern finally starts to do what I thought it was going to do possibly next Tuesday. We're going to have to wait all the way until about the 28th to start to see deeper troughs coming into the Pacific Northwest. And again, This is going to be an important trend to try to keep an eye on if this is actually going to happen, because what we end up getting out of this is seen here. The next 7 days, okay, we understand why we're drier across most of the country. We then play this 7-day sliding window of precipitation anomalies to here. Let's stop it right there. There we go. That's day 4 through 10. I had already thought we'd see better moisture for the whole of the Pacific Northwest and California. The models now want to bring that in fully into the late time period of November and then start to deliver better moisture return. Now, why is everything kind of so delayed here? Because this MJO pattern I guess I used it to try to understand that. But I think the problem is that we were probably more in phase 5 than I had anticipated. You can currently see it sitting there. It will move over to phase 6 soon, but it's going to spend some time in phase 5, and it's right over here right now. So for the next 7 to 10 days, we're going to get the phase 5 view of the atmosphere, which looks something like this. You see the troughs take a little bit extra time, see it right here, to get into the west coast, and we see some ridging at times. And there's that deeper trough. So that's a misstep on my part. I think I was just a bit too anxious to see the whole thing open up again. But it will eventually do that. And I think it'll eventually get into phase 6, which then at the end of this month and to start December will start to deliver more of that moisture again. You remember that? That's the trough off of Japan, the ridge over the Aleutian Islands, the trough in the Gulf of Alaska, and more ridging events that move. They migrate east but sit here. I also think we might see a little bit of MJO phase 7. And the idea here is that you just continue to keep high momentum coming through the Pacific. And that is maybe how we're going to see the month of December playing out. So this is the new update. This is the new update from the European model on December forecast. And again, you don't see really a lot of places across North America that are going to favor drier conditions. I think we're going to see a very active early start to winter, and it's going to start on the west coast as this pattern takes shape. The likelihood of seeing multiple shots at colder air, I think it's there. This is what the newest December temperature outlook looks like. Now remember, it's December, so the temperature pattern is going to be volatile. Wherever you see the blues, that would probably just represent where there are more frequent shots at cooler air versus the reds in here, which would represent maybe where we hang out a few more mild days than cooler days. This is good. This actually mimics the newest update that was released by NOAA just the other day. So we can see that across the northern tier of the United States, multiple chances of having that cooler air. If there's a place that stays warmer, it's probably going to be in the southwest. And you can also see that they're predicting the above average precipitation coming into the west. What I don't like about this is this particular setup may make the rain shadow, that's the rain shadow that comes off the front range of the Rockies, it could extend into the hard red winter wheat belt, which we've been covering for the last couple of weeks, is showing up very dry in parts of western Kansas, pockets of the panhandles, but Colorado into Nebraska. So this is not a good situation for them overall. Now, where do we take this from here? I want to come back to this ocean temperature map, and I'm going to talk about La Niña, because I've been discussing for a while that I think this La Niña, although it's very strong right now and will continue to strengthen through November into December, I don't think it's going to last much beyond that. And some of the clues for this are actually taking shape right now in the Indian Ocean. So remember, we looked at the QBO, we've looked at the trade winds, and I want to talk about these trade winds in the Indian Ocean. Because to keep a really strong La Niña, it helps to have westerly wind bursts in the Indian Ocean, like what we've got right now. See this? That's what I'm talking about. That's the westerly wind burst, while the easterlies are coming over here, giving us an MJO somewhere in phase 5 and 6. Now, we want to know if these are going to continue, because whenever you see strong westerly wind bursts like this, you get rising motion here, sinking motion here, and it's all a part of what we call the negative phase of the Indian Ocean dipole. Now, the Indian Ocean dipole was negative for all of last year. It then really dropped off this summer, and it has since been making a recovery. It's difficult to maintain a strong La Niña if the Indian Ocean dipole goes positive. If it stays negative, it is easier. If it goes positive, it's harder. And what we see is that from the Australians, the Canadians, the Europeans, and the British, their forecast of the Indian Ocean dipole by December is no longer negative. And going into January and February, they're now predicting a positive view of it. Now, what does that mean? That means we will lose these westerly winds. And if they're gone, we'll have normal trade wind flow here. And that's going to affect the way that the trade winds across the Pacific, which are the characteristic feature of a La Nina, they're going to be influenced. That will allow the MJO to start to move around. That will adjust the Pacific jet stream position, and that will help slowly erode the effect of La Nina. So we're just going to continue to build that story going forward. Now, thinking about all of that, we did have new data released from the IRI multi-model probability forecast. This is out of Columbia University. They work very closely with the CPC. This is their new global update for December, January, February. Now, for most of that time period, Australia will continue to see above normal precip. There's concern about the drought continuing in parts of Asia. We can also see, as we talked about this week, the risk of drier conditions in southern Brazil and Argentina, while normal precipitation is expected on Brazil's main growing areas to the north. If you come in here to North America, let's zoom in there, what you end up having is a typical La Nina view. Drier to the south of that line. Now, if I could make an adjustment to this, and this is not calling criticism on these guys, this is just what I would do. I don't think it's going to be this dry throughout the January-February timeframe south. I think during that time period, we're going to have a much more active Pacific jet. I do believe it'll eject in the Ohio River Valley. I think it'll enter a bit farther to the north, but I will be watching Hawaii. What I'm watching for here is if we just completely lose this La Nina signal, we could start to see the Pacific jet splitting here. Not over the west coast, but splitting in the Gulf of Alaska right into this area. And that would start to develop some kind of component of a subtropical jet, which is something, to be honest, we desperately need to see. But the temperature forecast for this winter is not mild. It is not mild for much of North America. And do we really see a lot of warm days south? I don't know. I think we're going to see, because of what I explained earlier with the polar vortex, the way that Siberian and North American snow cover is set up, I think we're set up for a cold winter this winter. Now, I mentioned Europe, and if we come over and take a look at Europe's temperatures, you see that right now the models are kind of going after a mild bias. But if we just fast forward this a little bit into January, February, March, now using the heart of winter, you see that the risk of staying mild shifted south. We got a lot better or higher probability of staying drier to the colder to the north. So I want to just keep that all in perspective as we go forward. I think there are significant risks of cold air in Europe, and right now those risks are being borne in Siberia. Okay? Now, to finish this up, I do want to show you the latest update from the CPC model. This is their December, January, February precipitation anomaly. And so they're expecting the jet to enter and eject. And they're also keeping the temperatures quite cold across the northern tier of the United States. This is La Nina to the T, but I expect it to be modified as soon as that La Nina begins to lose its influence, which for me, I'll just give you my dates again. I think during the 30-day time period of December 15 to January 15 is when we'll start to see it back off. Now, where this is also going to be important is in South America. Now, over the last week, especially last weekend, we saw better rains hit big sections of Argentina. And their root zone soil moisture has come up. There's still dry conditions in and around the Paraná River from Cordoba to Santa Fe and back to the north. The drier conditions you see here are pretty far to the north. This is northern Mato Grosso over to Rondônia. And I'm not overly concerned about the dryness you see here. What I am concerned about is the groundwater. You see, during any drought like the one that Argentina is currently dealing with, you can temporarily bring up the root zone soil moisture. But if you don't have the deep reserves of water beneath it, there's going to continue to be, possible issues. And just looking out there, this is the new 15-day forecast for precipitation anomalies. We're starting to see better rains north and east of that line, but drier into Mato Grosso do Sul, down into Paraná, and into Argentina again. So the models are kind of picking up on that. Could we get better rains into Buenos Aires? Yeah, we could. I've seen that in multiple model runs this week, and it seems to be reflected quite well there. But the new long-range data does show that for the month of December, if there's going to be an area with drier risks, due to what the La Nina is currently positioned to do, it's going to be from Paraná to Rio Grande do Sul, parts of Paraguay and Uruguay, and Argentina. If this verifies through the month of December, that will push the northern growing areas quickly along and likely continue to provide what's needed to have a very, very large soybean crop in the northern growing regions. So we've got a lot to be watching here. And again, so much of what I discussed with you today hinges on the behavior of two things. The polar jet stream pattern, which is related to the polar vortex and other things like snow cover, and then what La Nina and the MJO do together. So we'll watch it. I'll talk to you again next week. Just a quick thing. I am not going to do a long-range video at the end of next week on Thursday. I'm just going to spend some time with family, but I'll do reports on Monday, Tuesday, and Wednesday. So I look forward to talking to you next week. Thanks.